Sally Thompson is Assistant Professor of Civil and Engineering, Environmental Engineering here, and her research focuses on eco-hydrology, surface hydrology, spatial ecology, arid and semi-arid watersheds, and a whole lot more. Please welcome Sally Thompson.
I'll let you deal with that, thanks. Well, after observing a biologist and an economist show us more statistics and figures and graphs than we could shake a stick at, as the engineer speaking this morning, I'm going to begin with some poetry, talk a little bit about law, follow that up with the history of water management in certain parts of South India, and then I think I've got two graphs. So apologies for that very cliched approach. The reason I'm going to be doing all of that is to try to express something about the context of a research project that we are in the very early phases of, which, like Max's work, is also set in India, a little bit further south, maybe a little further inland, in a river basin, the Calvary, which is one of the major river basins of South India, and more specifically, one of its sub-watersheds, the Arkvathy Basin. As I started to think about pulling this particular talk together, I'm much more of a Luddite than Max, and I found myself short of reading material on the bus, so returned to a wonderful water history of Australia, a book called The Water Dreamers by Michael Cathcart, in which I realised to my surprise that one of the household names in Australian poetry, a guy called Banjo Paterson, every Aussie kid grows up knowing Banjo Paterson's poems, I realised that Banjo had not just written about people chasing brumbies through the snowy mountains, but also had written about groundwater. And the lines from Banjo Paterson's poem that are quoted in Michael Cathcart's book go as follows. The drill is plunging deeper at 1,000 feet of level, and if the Lord won't send us water, then we'll get it from the devil, for it is flowing, ever flowing, deeper down. Those lines were written in 1896 as the expansion of groundwater irrigation was really exploding in Australia, and I think they encapsulate something very fundamental about our issues with groundwater, a long-standing perception that if we could just get that drill down a little bit deeper, we would tap this essentially infinite resource. And this, I think, is going to be very important for the context of what's going on in South India. This image is not from South India. This image is, in fact, from Florida. It's the Alapaha River disappearing down a sinkhole. And I'm putting it up here because if you go to Google Images and you search for groundwater and photograph, this is the first photograph you see. You go through many, many, many conceptual diagrams of groundwater before you ever find a photograph. And in fact, every photograph you will see trying to convey the notion of groundwater will in fact show you a surface water resource that is somehow connected with groundwater. And this, I think, is another issue. Groundwater is a tremendously intangible resource. We do not have an elevator shaft with which we can descend those 1,000 feet into the earth and look at the wet mud or the saturated sandstone or whatever it is that comprises the groundwater resource. We don't have a charismatic set of waterfowl and beautiful springs and things that we can attach ourselves emotionally to. So we have this intangible, difficult resource that most people don't have a personal connection with, which is somewhat hard to manage, therefore, at a social and cultural level, perhaps. These affective blind spots are in many ways reflected in what I would describe as a legal blind spot. And whether we are in parts of the United States, in Australia or in India, we actually share some commonalities in our legal tradition which derive from British common law, not everywhere, but in many places. And groundwater under the British common law is managed by something known as the rule of capture. And just to dispel any misconceptions that we might be dealing with a, say, up-to-date legal framework here, the rule of capture itself derives from Roman property law, which gives me the opportunity to pretend to be able to pronounce Latin, which I really can't do. The relevant clause is "Quies est solum eis est usque ad caelum et ad inferos," which translates... Was that all right? I have no idea. They stopped teaching classics by the time I had hit school in Australia. This translates as, "For whomsoever owns the soil, it is theirs up to the sky and down to the depths." which is great if you happen to buy a parcel of land sitting on top of, say, a gold seam, and you would one day like to mine an immobile resource from beneath your soil. What this says is that the resources that exist below ground directly underneath your property boundaries belong to you. This is obviously a disastrous way to try to manage a resource like groundwater, which is no great respecter of property boundaries, but instead will flow from one location to another. There are two consequences of the rule of capture being applied to the management of groundwater. And the first of these is that essentially, in most places, groundwater is unregulated. It's regulated through the system of property rights. That's in stark contrast to the way that we tend to regulate our surface water resources, where more commonly we will say, look, this river is essentially common property. This belongs to the state. The state will allow a water allocation or a water use right and will manage it as a common resource. Instead, groundwater is managed in this very property rights and individual-centric way. And the second consequence of this is a very logical corollary of the first, namely that he with the biggest pumps longest, laughs loudest, and wins. In the absence of a managerial framework that can treat groundwater as a common resource, what we see played out time and time again is a very typical tragedy of the commons, also commonly known as the race to the bottom. Well, none of this was a particularly big problem in South India when institutional water management first started to come into play, because that was back in the 1300s and was associated not with groundwater pumping at all, but with surface water management and the construction of a tremendous network of rainwater harvesting systems. These systems are known as cascading irrigation tank systems. This is an example of a tank today. Obviously, this is not a photograph from 1300. And these are quite incredible structures. Walking around South India today, most of the tanks have become defunct, so you can stand in what was once the bed of the tank and look up at a 10-metre high wall composed of enormous blocks of granite masonry, which may stretch for as few as 50 metres or for as far as about 2 kilometres. These things dot the landscape. This is just pulling a random image from Google Earth and colouring in the places where I can still see the tanks. There are locations where in any other continent, what you would see as a streamline, a narrow meandering channel, is really replaced by a network of tanks connected by broad areas of irrigation. And these tanks are almost the opposite of a dam, in the sense that if I were to try to construct the kinds of dams that we do here in the United States, or did during the era of Great Dam construction, what we were doing was trying to capture as much water as we could with as small a dam wall as we could get away with. By contrast, these are distributed systems that are looking to have the largest dam wall they can get away with, because their whole purpose is to create a little bit of gravity head, a little bit of stored water that they can use to continually feed irrigation channels throughout the dry season that persists after the approximately 6-month monsoon in this part of India. Amazing social systems grew up around these tanks. You'll see very, very commonly that the small villages in this part of India are associated with a tank. These were very productive. The way that they were managed is that a tank custodian would be appointed for each village. And this guy was essentially a water engineer. He managed the maintenance and the allocation of water from the tanks. And what he really did was coordinate all of the workers in the village to come together and work on these tanks as a communal resource. And the way that this was sustained is that the tank custodian would be paid through a tithe of all of the farmer's production. So he had a really good incentive to do his job well, because if he didn't do his job well, production levels were low and obviously he did not get paid as much. So there was this very symbiotic relationship between the management of water, the social structure in these villages, and the agricultural production of this area. Well, inevitably it was the British who mucked it up. Rule of capture, messing up India. They mucked this up really by centralisation of administrative functions during the era of the British Raj. And during the time of British administration, these tank custodians became employees of the state rather than employees of their individual village. And with that incentive to get local agricultural production doing really well out of the way, suddenly those tank administrators and custodians weren't doing their job quite as well, and these tanks began to fall into disrepair. They silted up,
their infrastructure became damaged, and people switched to alternative ways of getting water, principally the use initially of surface wells, and then as the expansion of the electricity grid and provision of very heavily subsidised power permitted it, increasing use of deep groundwater reserves. So this is me standing at the bottom of one of these tanks. This great big granite pillar is a water level marker. That entire horizon up to where you can see the trees is the base of the tank. You can get a sense of some of the missing water that in fact is what's motivating us to work in this area. Okay, final piece of background. At the same time that the British Raj was inadvertently messing up water management in Indian villages, they were also engaged in a wonderful legal battle. Actually, they were engaged in many battles, particularly between the Madras Presidency, which is where the English were housing most of their administration, and in South India, the princely state of Mysore. Just like saying the princely state of Mysore. Mysore had managed to win many battles against the British and at this point was an independent entity. However, Madras and Mysore share that Calvary River basin together. And so I should say that Mysore and the princely state of Mysore essentially corresponds to today's state of Karnataka, which I'm going to be talking about. So these two entities started having a fight about water because Mysore wished to construct dams for irrigation, which would impede the flow of water to the coast and to Madras. They took their sweet time about it, but after a period of about 30 years, they'd managed to negotiate an agreement, which neither of them was very happy with, and they have been fighting about the use of water in this basin quite literally ever since. Nasty, acrimonious talk about interstate water conflict. This is a particularly unpleasant debate. That, I hesitate to use the word resolved, but I'll say it was resolved, probably not in any permanent sense, in February of this year, with the agreement of a national water sharing plan between the 4 states in the area. So these are the 3 pieces of context I really want us to have when starting to think about this basin. We don't have good management of groundwater. We do have 120 years of having a great big fight about surface water resources, and we have a traditional water management system that in the past 100 years has switched very firmly to being dependent upon groundwater resources. All of which brings me to the study site that we're starting to work in, which is the Arkvathy Basin. Like many words in India, there's about 5,000 ways to spell Arkvathy, so you'll see many different variations on this, and apologies if anyone has a preference other than this one. The physiographic context is on the left. We are still in the southern part of India, the Calvary Basin being that large river basin between Karnataka and Tamil Nadu, and the Arkvathy being this relatively small basin right on the eastern boundary of the Calvary. It's an interesting place to work because the entire red splotch up on the right-hand side there, this is a land use map and I don't know how visible it really is up there, but that large red splotch is the urbanisation associated with the city of Bangalore. Bangalore is an amazingly wealthy and rapidly developing city by Indian standards. I was blown away in flying into Bangalore and comparing it to other cities I've been to in India. It's more reminiscent of Dubai in some respects than in most of the other cities I've been to in India. So we've got this very large, very wealthy city growing up on the boundary of this basin, and then this essentially agricultural hinterland through the rest of the Arkvathy Basin. There are several surface water reservoirs here, 2 major ones on the Arkvathy, neither of which is currently being used for water supply to Bangalore, although both of them were historically important. And the reason that neither of them is currently in use and that Bangalore is pumping its water from 200 kilometres away in the Calvary is because the Arkvathy River has stopped flowing. To give you an it's a graph. To give you an indication of this, what we're plotting on the left here are flows entering the southernmost, so the most downstream of the reservoirs on the Arkvathy River from the period from the late 1930s onwards. And what's really evident is that following about the mid-1970s, flows in this basin have dramatically declined. And in several years in the past decade, we've had no water actually reaching the reservoirs from this once fairly significant river system. The image on the right was taken in July of this year in the middle of the monsoon season, a completely normal and wet monsoon season. This is the channel of the CULMINATION River, which is nominally the part of the Arkvathy that still flows. Not a whole lot of evidence of water in these channels. So the reason that we are now engaged and are working with our partners at the Ashoka Trust for research in ecology and the environment is to try to work out where this water has gone. And we are taking what may seem like an unnecessarily broad-minded approach and looking at multiple hypotheses. The first of these is to ask whether rainfall has changed. Clearly, if we're not seeing flow anymore, it could just be that we are in the middle of some protracted drought. Here we have some basin scale maps. These were These were put together in what I'm sure was a very exacting scientific study in 2012 last year. This is the Calvary Basin, and what these maps are indicating is that at the basin level, we've in fact seen increases in rainfall and no change in the number of days in which rainfall is occurring. Looking at rainfall gauging stations, again, this is near the T.G. Hulley Reservoir at the southern part of the basin, although there's certainly variability and an evident drought in the 1980s, which impacted much of South India. Again, there's no real indication that we are undergoing any kind of atmospherically induced drought. Well, the next question might be the question that Todd raised, namely, have evaporative demands started to increase? And one of the other things we know is happening in southern India, as Max has been telling us, is that temperatures are increasing. There's been about a 1 degree temperature rise in this basin. Yet at the same time, and I apologise for this plot, this was the most recent paper I could find on this particular subject, at the same time, empirical observations right across India suggest that evaporative demand is decreasing. So this plot is showing 4 maps, each is for a different season. The take-home message here is that if you see an empty circle, it means that the rate of evaporation from an open body of water, an evaporation pan, has declined over the past 40 years. And indeed, this is almost certainly attributable to the ABC, the atmospheric or Asian brown cloud, and the fact that there's just less light getting to the surface of the land where evaporation would take place. So although we've seen increases in temperature, it appears that in terms of evaporative demand, they have largely, across most of India, been offset by these changes in radiation. The next question that we are spending some time on is trying to understand whether physiographic changes in the river channel have actually prevented this river from getting its water to the reservoirs. And certainly there is extensive encroachment in the channels. This is an example of sand mining in the bed of an old irrigation tank. So there's now a lot of construction going on, lots of demand for concrete in the area. Sand is a pretty important resource if you're trying to lay a lot of concrete pads, and these are readily accessible sources. At the same time, again, this is a photograph from the middle of the monsoon. This theory of channel encroachment, which my colleague at Atria Vina likes to refer to as the million puddles theory, so instead of a river, I have a million puddles that are all just drying up or draining. It was surprising to us, if this were true, that we do not see any evidence of water being ponded at large scales. Almost all of those irrigation tanks, for instance, are now dry and have been running dry for the past 15 years. At the same time, this particular hypothesis is far and away the major focus of official concern and management efforts at the river. These are some quotes from articles in newspapers in the past month referring to the Arkvathy, from the Deccan Herald. Rampant sand mining, quarrying coupled with industrialisation have led to the virtual death of the river Arkvathy. From the government water corporation that manages the Calvary River, reflecting on the Arkvathy River, widespread sand quarrying, formation of layouts, encroachment by industries, preference for water-sapping trees, and switching over to commercial crops has narrowed down the river course. And because I have primed you so very well, I'm sure that, like me, you are noticing a certain hypothesis that we've not yet talked about, namely that in fact something very dramatic has been changing with groundwater and groundwater management in this basin. And these are some images from the United Nations Environment Programme. Max was telling us about the Gangetic Plain, which is the area in bright red. But if we move further down into the Deccan Plateau, down in the southern triangular part of India, that's the area that the Arkvathy Basin is within. And we're seeing that even by the year 2000, 10 years ago, we were looking at anywhere between 20 to 300 millimetres, so that's up to a foot, of mining of groundwater beyond what could be replaced in this area. Surveys that Atria is conducting in the villages confirm this at the level of individual farmers and individual managers. They're seeing water table levels that have really dropped by up to 60 feet in the past few decades. This is not a simple problem. I've probably set it up to seem like clearly groundwater is the culprit, but there's a lot of other stuff going on. The issues around plantation forestry are very real. And one of the very interesting things that we're seeing in terms of the intersection of human and natural systems here is that the expansion of plantations seems to follow the transport boundary of where you can get to a city like Bangalore. So if we go to a farm near the highway to Bangalore and say to the farmers, how much would I have to pay a farm worker? They'll say, oh, you know, we have to pay them 500 rupees an hour because they can jump on the bus, go to Bangalore and earn that for being a security guard. You can't economically grow a labour-intensive crop like a horticultural crop that has to be harvested 3 times a year while paying your workers 500 rupees an hour. So there are strong incentives associated with economic change in the basin to switch the crop type, and we don't really know what the flow-on effects of that into the hydrology of the system would be. So there's things that we're getting into to try to understand that. But what I want to step back from here is to maybe have a little bit of sympathy for the state of Karnataka. Because if we had spent the past 120 years having a very loud fight and a very nasty fight about surface water resources and had ended up with an agreement which was entirely based on flow in a channel and nowhere mentions the fact that groundwater and surface water resources are interchangeable and interact with each other, and we were already getting a lot of pressure to deliver more water than we can to our neighbouring state, I think it might be much more attractive to turn around and blame global warming as being the ultimate cause of that problem than to open the bottle and let the genie out that said, jeepers, actually maybe our entire legal system and its way of dealing with these resources is flawed, and what I actually have to do is go tell all my thousands of farmers that you've got to stop pumping water that is currently sustaining your livelihood. There are significant political and policy pressures that make this a difficult hypothesis to raise in Karnataka. And with that in mind, what David asked me to reflect on was, well, what's the role for an institution like the University of California or a non-government association like ATRI? And I'm entirely stealing a phrase here from Roger Pielke Jr. I think we have a role to play as the honest broker, because personally I do not have a stake in the answer to this question. I want to find the right answer to this question and understand where this water has gone. And what we find as we talk to colleagues in India is that unless they're completely independent from government, they have a great difficulty in acting in as independent a way as we can as an outside party. So we see a role there in trying to mediate the science questions and being detached enough perhaps to be independent. Meanwhile, of course, what we do see throughout the Arkvathy Basin are that the surface wells have gone dry, that in the middle of the monsoon, villagers were telling us that the shallow groundwater bores were no longer producing. And it all becomes a little bit reminiscent of one of the final paragraphs in Banjo Paterson's poem from the 1800s. It must be down beneath us, it's down we've got to go, though she's bumping on the solid rock 4,000 feet below. And it's time they heard us knocking on the roof of Satan's dwelling. But we'll get artesian water if we cave the roof of hell in. Or we'll get artesian water deeper down. Thank you.